Hello. So the last time we found values of sine 45 degree, cos 45 degree and tan 45 degrees. This time we'll try finding values of sine 30 degree, cos 30 degree and tan 30 degree. Now to find these values, firstly we'll observe this triangle. Let's label this triangle. This I'm labeling as O, which is the center of the triangle. A is the point from where at which we have the perpendicular of the triangle, and then this point is B. So here we observe that. Let me just erase this. Yeah. So here we firstly observe that angle AOB is 30 degree, angle OBA is equal to 60 degree, and that is by angle sum property of triangle, as we have taken angle OAB as 90 degree. Alright, so this much is clear to us. Now we'll bring our focus back to the triangle which we have, and to find the value of sine 30 degree, cos 30 degree and tan 30 degree, we firstly, since we have a 90-degree angle here as well, so let me just draw it for you. Let me take another color. Let's take yellow. This angle is 90 degree. We have 90-degree angle. Now 90-degree angle can be written as 3 into 30 degree. That means it can be subdivided into 3 30-degree angles. So that's what we are going to do here. And what does that mean? It means that so this angle then will be 30 degree, and let me take another color. Then this angle will also be 30 degree. Then I label this point as C. So from C, let me just label this as, this is your x-axis, and this is your y-axis. So from C, dropping a perpendicular on y axis. So that means this line, it is, here we have our perpendicular which is 90 degree. Now what I do is, this point, let's label this point as D. Then what I do here is, again we drop a we extend this perpendicular here. So this angle will also be 90 degree. Why is it 90 degree? Just think about it once. So extending our extending CD. So here also we have 90 degree. Then this point we label as E. Then join O to E. So then we join this point. Okay, let me just erase this and draw a proper line. Oh my god. Okay, yes, we are back. So I'll just draw the line here. Sorry for that mess up. Okay, so we have a line here. Now what we'll try to firstly prove is that, let me just make some space here now. So this construction, I hope it's clear to you, and you can pause the video if you want to go through the construction again, what we have done till now. Now let me take another color. We will prove that triangle OED is congruent to triangle OCD. Why we are doing it? For when we are able to prove that triangle OED is congruent to triangle OCD, then we'll have our this angle also as 30 degree, And if this angle is 30 degree, firstly in this triangle we see that this angle is 60 degree. This angle is 60 degree by this same property, right? And then from there we'll also get this angle as 60 degree. Now first thing which we see is that your uh, OE is equal to OC. Why? Because they are radii, right? And you also have angle EDO is equal to angle CDO. They are 90 degree. And you also have DO is equal to DO, common side. And we know that if we have right angle triangle, then using the property that one right angle is equal, one side is equal, and hypotenuse is equal, we'll get a triangle OED congruent to triangle OCD. Because see, from both these sides we'll also get, using the Pythagoras theorem, that your side ED is equal to CD, and then you can basically just apply your side property for the congruence, and you'll get both the triangles are congruent. Now we have found that both the triangles are congruent. Using this congruent property, what see we'll see that the angles are also equal. Using this congruency of triangles, this congruency of triangle, what do we see? We see that if two triangles are congruent, their congruent parts are also equal. So that means angle EOD is equal to angle what? COD. Congruent part of congruent triangles are equal, and we'll also have angle, and this is firstly 30 degrees, and we'll have angle OED equals to angle OCD, which is 60 degrees. So we got this, right? Let me just note this down here. This angle we got as 60 degree, and this angle also we got as 30 degrees. Now let me just erase this, and uh, let's see what happens. Now we see that, now let's bring our focus to the triangle. Which triangle? ECO. Now in ECO we see that angle OEC is 60 degree, angle ECO is 60 degree, and angle EOC is equal to angle EOD plus angle DOC, which is 30 degrees plus 30 degree, which is equal to 60 degree. So from here what do we get? We get that our triangle ECO is an equilateral triangle. Equilateral triangle. We know that any triangle which have all the sides as equal is an equilateral triangle, and since we got this, so all the sides are equal, that means all the angles, and all the angles are also equal, right? All the angles are equal, and from there we get this is an equilateral triangle. If all the angles of a triangle are 60 degree, we know that it is an equilateral triangle. So we have a triangle ECO as an equilateral triangle. Equilateral triangle. Since this is an equilateral triangle, what do we get? We get OE is equal to EC is equal to CO, right? And we know that OE and OC, that is CO, is the radius. So this will be also equal to the radius of the circle, and we have taken this radius of the circle as 1 unit, right? So we got this. Let's just keep this part aside for a moment because we'll see where this part is useful. I'll keep it here, and rest I will erase. So just erase it, and from here we will get now coming back to our main triangle. So we need to find what? Sine 30 degree, right? And sine 30 degree, basically, let's see in the triangle, ODC, right? I mean, both of these triangles are also congruent. Which triangles? Triangle ODC is congruent to triangle OAB. With this you can prove very easily, so I'm leaving it for you. Now, since it's an equilateral triangle, coming back to the equilateral part, it's an equilateral triangle. What we can do for an equilateral triangle, uh, which triangle we are considering? Firstly, we need to specify that we are using the triangle ODC. So we have OC is equal to 1 unit, and we will have CD as half unit. Why? Because we have D as midpoint, right? We have already proved these two triangles are equal. So the two triangles OED and OCD are congruent. So we have ED is equal to your CD, and from there D is the midpoint. So CD is equal to half unit. Now we can use the Pythagoras theorem to find OD. So OD square is equal to your OC square minus CD square. OC square is 1 unit and CD square is 1 by 4. From here you will get it as 3 by 4, and from here you will get your OD as 3 root of it, which is, I'm sorry for this, which is basically root 3 by 4, right? Now I'll just erase the parts which we don't need, and we'll keep the parts which we need. All right, we'll just erase all of this, and we'll keep this part. This part is something which we'll be using, so let's just take this part. Okay, I'll just note it down again. So we have OD is equal to, the magnitude of OD is root 3 by 2. I'm sorry for this error, root 3 by 2. All right, so we have reached till here. Now after this, what do we do? The thing which we are going to do now is we are taking triangle OCD, and as I said, this triangle is congruent to triangle OAB, which you can prove, right? How? OC is equal to OB. Have I done some mistake? OCD and, oh sorry, this will be OBA, right? Whenever you're writing the congruent triangles, make sure that you write whichever part is corresponding to the other part. Here OC is equal to OB as they are radius, and then your angle O, your angle DOC is equal to angle A OB 30 degree, and your angle OCD is equal to which angle? OBA 60 degree. From here you will get both of these triangles are congruent. All right. Now congruency has been established, so I can just simply find sine 30 degree in your triangle uh, in your triangle OCD, and with, and that will be true for triangle OBA. So in triangle OCD, what you see is sine 30 degree is equal to what? Your sine 30 degree is CD upon OC. CD is your half unit and OC is your 1 unit. So this you will get as half, right? Now you're finding cos, okay. So sine 30 you have got as half, right? From here you will get your sine 30 as half. Okay, let us just write it down. This is half. Now coming back to cos 30 degree. Cos 30 degree is basically your OD upon OC. OD you have found out as root 3 by 2 and your OC is 1 unit. So this is basically root 3 by 2. Okay. So cos 30 degree also you have found as root 3 by 2. I'll write this down here. Cos 30 degree is root 3 by 2. Alright. Then your next thing is what? Tan 30 degree. Tan 30 degree is CD upon OD. CD is your half unit, OD is your root 3 by 2. From here you get the value of tan 30 degree as tan 30 degree as 1 by root 3 and this is how you have found all your values of cos 30 degree, tan 30 degree and tan sine 30 degree. Okay, so I'll just put it up here. Using the same logic, same construction, you can find the value of sine 60 degree, cos 60 degree and tan 60 degree from here itself. For that, I'll try to discuss it in the next lecture, next part of the video. But till then, remember this part, go over it again and try finding the values for sine 60 degree, cos 60 degree and tan 60 degree. Thank you so much.